I'm a civil engineer by training and specializing in water engineering, water resources management. And most of my work is involved in urban water and hydroinformatics. So we're using the power of information and computing technology to plan for better utilization of water resources. And water is a vital natural resource and is quite important, not just for maintenance of society infrastructure, but also for maintenance of life, basically. And it is of utmost importance, and also for industry, agriculture. It's quite interesting that 70% of our water is being used actually for agricultural production. We take most of water infrastructure for granted because it's out of sight, out of mind, really, because it's buried underground. But quite a lot of that infrastructure in the UK originates from the Victorian times. And it's not just the UK, the rest of the world is having the same problem. Old infrastructure need to be maintained, replaced. There is quite a lot of investment involved in that. And let's face it, we don't have enough funds to replace everything, say, every 10, 20 years. So what we need to do, we need to focus investment into this water infrastructure, find out where to invest the best for the maximum impact. And some of the work that we have done was to optimize investment over a period of time into infrastructure assets to keep them going. Because in the UK, the way or how much we invest in renewal of our water networks or sewer networks, the rate that we invest is so low that they will have to last several hundred years at that rate that we kind of renew it every year. So we now develop modeling methodology, decision support methodologies to plan in most efficient way how the funds are going to be spent and where they're going to be prioritized in order to keep the level of service that we provide to urban population of this country. One thing that is quite interesting about water is that we, when I say we, I mean globally on the planet. We haven't decided whether water is a right or is it commodity. And for example, in many poor countries, the proportion of income that people spend on buying water is much higher than in developed countries. Like, for example, when we pay for petrol, we gladly pay for it. When we pay for water, usually we complain about the cost of water. But water is not highly valued in general, despite the fact that 1 billion people out of 6.5 billion that live on Earth actually don't have access to clean water supplies or don't have access to sanitation. And that's also interesting because out of the total amount of water available on planet Earth, we only can use less than 1% of that water. Most of it is salty, in glaciers or groundwater, so it's very difficult to get that water. The other problem is that timing and location of where water is available is not actually in sync with timing and location where it's needed. And that's what engineers do. That's why the infrastructure is there to move water from where it's available to places when it's needed. We use modeling tools to model how new and improved infrastructure could help people get better access to water, how we can reduce wasteful usage of water. For example, in this country we still lose 1/4 of the water that is being abstracted, that's been treated, pumped, and brought into the system, but before it gets to the customer, it's lost. So there are ways of using these modeling tools to develop better understanding of how we can use water more efficiently.